reversible reactions and equilibrium. So many students confused with some of the options that are related to chapter 8. So I will explain that which factors are actually related to equilibrium, because the factors that are related to equilibrium position and to the rate of reaction, they are different. Okay, not all of them are same. So now let's see one by one which statement about a reaction in equilibrium is correct. For equilibrium, you need to remember that at equilibrium position nothing stops, not the formation of reactants or the product. Only the main difference is that in equilibrium the rate of forward and backward reaction is always same. The rate of reaction is same, not the concentration of the reactant and product. If they ask you about the concentration of reactant and product at equilibrium, it should be constant. You have to use the word constant. Okay, so the rate of reaction of forward and reverse will be equal at equilibrium, but the concentration of the reactant and the product will be constant, not equal. So now we can see this option. Which statement about a reaction in equilibrium is correct? Both the forward and backward reaction are proceeding at the same rate. Yes, this option is right. Okay, the rate of forward and backward reaction is equal. So it is equal. It is at the same rate. So that's why this option is right. Why not option B? The forward, not the backward reaction is proceeding. It's wrong. The reaction never stop in equilibrium. It will be a continuous process. So this option is wrong. The amount of the product present is no longer affected by changes in temperature or pressure. Wrong. You can change the position of the equilibrium by changing some factors. And these factors, there are three factors. One is temperature, the other one is pressure, and the third one is concentration. Okay, not catalyst. Sometimes the student get confused. They think that catalyst can also change the equilibrium position. That's wrong. They get confused with rate of reaction. Rate of reaction is different thing. Equilibrium position is a different thing. Okay, I will explain to you in the next question. So the amount of the product present is only affected by change in pressure. Wrong. It's not only affected by change in pressure. It can also be affected by change in concentration or by the temperature. So option A is the right option. Let's see this question. Steam reacts with carbon in an endothermic reaction. Which conditions of temperature and pressure would give the largest yield of hydrogen? Now the rate of reaction, we already have seen 4 or 5 factors that are responsible for increasing the rate of reaction. So if you increase those factors, the rate of reaction will be higher. But this is not the case in terms of the equilibrium position. Okay, an equilibrium position, increasing and decreasing depends upon the situation. For example, there are 3 factors that can affect the equilibrium position. Okay, these factors are: first is temperature, the second is concentration, and the third one is pressure. Temperature always depend on endothermic and exothermic reaction. We already know that exothermic reaction always release the heat, right? So when they release the heat, it means they don't like high temperature, because their job is to give out the heat. Why they will absorb heat? They don't like to absorb heat. So you cannot give high temperature for exothermic reaction. So if the reaction is exothermic, you have to give a low temperature, so the speed of the reaction will be towards the product. Okay, you will get more yield of your product if the temperature is exothermic. So now let's see this condition. Which conditions of temperature and pressure would give the largest yield of hydrogen? Where is hydrogen? It is our product, and this reaction is endothermic. What does it mean? It means the forward reaction is endothermic. So means for endothermic reaction always like to have high temperature. They like to take temperature from their surface. So it means to provide high temperature for endothermic reactions so that you can get more product. Okay, so the temperature should be higher because the reaction is endothermic. So endothermic will always increase the product reaction. Okay, you will get more product. It will change the equilibrium position towards the product, towards the right side, if you give high temperature. Okay, so these two options can be right. Now let's come towards pressure. Which factor will decide the pressure equilibrium? Like it will move towards left or right. So the thing you have to look for the pressure is that the number of the moles of gases present on the reactant side or on the product side. If you look here, we have just 1 mole of a solid carbon, right? So it means it's not a gas. You cannot use the pressure for this one. Let's see how much we have gas of water. 1. So 1 mole of water we have here, 1 mole of gas in reactant. And how many moles of gas in the product? 2. 1, 2, right? So the reactants have just 1 mole. The product has 2 moles of a gas. So it means if you increase the pressure, increasing pressure always favor the one that low in number. And which one is lower? Of course, your react. But we have to increase the yield of hydrogen that is actually in the product. So it means you cannot increase the pressure, because if you increase the pressure, the equilibrium will shift towards the left side. Okay, so what will be the conditions now? You have to lower the pressure so that it more don't move towards the left side, and you just get your more product, that is H2. So lower the pressure will help to get you largest yield of hydrogen. So option B is the right option. Let's see another example so it will be more clear to you. In the Haber process, nitrogen and hydrogen are reacted to make ammonia. The reaction is exothermic, which condition produce higher yield of ammonia. So ammonia is on the right side. So it means we have to shift our equilibrium towards right side to get more ammonia. So we have only two options, the pressure and temperature. So temperature is dependent on exo and endo. They are already have given you information that the reaction is exothermic. What does it mean? It means you have to give a low temperature, because exothermic reactions don't like high temperature, because they are actually giving the temperature to the surroundings, so they will not take high temperature as a option. Okay, so they will always like to have a lower temperature so they can give you more temperature to the surrounding. So that's why the temperature you will be using for exothermic reaction is always lower temperature. So these two options are the right. Now let's see for the pressure. If you see, the number of moles will decide the pressure. Answer. How many moles of nitrogen we have here? 1. 3 moles of hydrogen. So total 4 moles we have of gas in reactant, and in product we have just 2 moles. So which one is less? It's the product. When the product has lower number of the molecules, right, or the lower number of the moles of the gases, pressure will always help the one that is lower. So who is lower? Of course, ammonia gas. The product is lower. So if you increase the pressure, it will help to get you more ammonia, right? And that is actually we want. So maximum yield of ammonia we can get if the temperature is lower and the pressure is higher, because the moles of nitro and NH3 are ammonia are lower. So you can increase the pressure that is high. So option B is the right option. Let's see again another example. This is question 76. Hydrogen gas react with iodine gas to form HI in an equilibrium reaction. Which changes increase the yield of HI at equilibrium? So many students do the mistake by choosing adding a catalyst. I already have told you that catalysts only increase the rate of reaction. It has nothing to do with the equilibrium position. It will only change the equilibrium position of both the sides, so it will not help in the yield. Our target is to get more yield of HI, to get more product of HI. So how we can get more product is only temperature, pressure, and concentration can decide. So this option is not the right option to increase the yield. Adding more hydrogen gas. So if you see, hydrogen gas is in the react. So if you increase the concentration of the reactant, you will get more product. That actually we want, right? So if you increase the concentration of the reactant, the equilibrium will shift towards right side. That's what we want. So option 2 is right. Let's see increasing the pressure. So increasing the pressure always depend on the number of the moles. Which side of the moles have less number of moles? So now which side of the reactant or product? If you see, we have one reactant, this, and this is one reactant. So total we have 2 mole of the gas in the reactants, and how many product? 2 mole of the product. They both are equal, right? So now even if you increase the pressure or you decrease the pressure, nothing will happen. No change will take place. So it means pressure has now nothing to do in this react, because the number of moles are equal. Let's see for temperature. Of course, if you increase the temperature, the rate of reaction will increase, right? But what about the yield? Will the yield of HI will increase? Yes. Why yes? Because if you see, delta H is endothermic, positive. Okay, the reaction is positive, so increasing the temperature will favor the right side. It will help you to get more products. So option 2 and option 4 are the right option. That is option D. Question 77. Hydrogen reacts with iodine to form hydrogen iodide. Which statement explain why the reaction is faster when the pressure is increased at constant temperature? Okay, now here if you see, the reaction is faster. Now they are talking about the reaction is faster. They are not talking about the product, right? Because the product will not change. It will not move towards the left or right side, because on both sides the number of moles are equal, right? But only the reaction rate will increase if you increase the pressure. Increasing pressure always increase the rate of the reaction. And the reason behind is that when you increase the pressure, the volume of the gas will be decreased. So now more particles will come close together and they will have more chance of collision, right? So now let's see where we can find this temperature, this option. High pressure, the molecules are moving faster. Wrong. Only when you increase the temperature, the particles will move faster because they have more kinetic energy. Okay, so temperature can only speed up the particles movement, or it can allow the particles to move faster. So that's why it's only for temperature, not for the pressure. At high pressure, more of the molecules have required the activation energy. Again, wrong. Only activation energy is actually for the system, it's not of the particles. Okay, so this option is wrong. At high pressure, the molecules are close together. Yes, this option is right, because at high pressure, the volume will be decreased. So now more particles will come close together. So option 3 is right. Let's see about the statement 4. At high pressure, the molecules collide more frequently. Yes, because when they come close together, they will collide more frequently. So option 3 and 4 is right. That is option D. So option D is the right option for this. Okay. 8. Chlorine can be by the following reaction. The reaction is exothermic. Which change increase the yield of chlorine at equilibrium? So where is chlorine? If you see, it is in the product. So it means they want to shift the equilibrium towards the right side. This is right side and this is left side. Adding more HCl. If we add more HCl, it is in the reactant, right? So the product will be more. So I think this option is the right, because if you are increasing the reactant, you will get more product. Now we can see other option also. Adding more H2O. Wrong, because if you will add more product, the reaction will shift towards the left side. So that's wrong. Decreasing the pressure. If you decrease the pressure, it will always help the one that is more in number of moles. Let's see how many moles of the gas we have here. 5. How many here we have? 4. So it means if you increase the pressure, it will help the one that is less in number. But if you decrease the pressure, it will help the one that is more in number. So again, it will move towards the left side. That we don't want. We want more chlorine. So the reaction should shift towards the right side. Okay, increasing the temperature always favor the endothermic reaction, but this reaction is exothermic, so it means it will not favor this reaction. It will favor again the left hand side. Okay, so that's why only the option A is the right option. We have to add more HCl so we can get more chlorine in our product. Let's see question 79. Sulfur dioxide is converted to sulfur trioxide in the contact process. Which row describe and explain the effect of changing conditions on the reaction? Okay, they are using different catalysts for 50 temperature. Okay, so if you change the conditions, for example, if you don't add a catalyst, the effect on the rate will be lower. Yes, if you remove the catalyst, the rate of the reaction will be lower. That's right. We will see the explanation later. If you increase the pressure, it will give you a higher rate of reaction. Yes, that's right. If you lower the temperature, the effect on the rate will be lower. Yes, lower temperature will always give you low rate of the reaction. Lower the pressure. If you lower the pressure, the rate of the reaction will be higher. That's wrong. Increasing the pressure always increase the rate of reaction. So this option is wrong. Now let's see the explanation. First explanation, we can start here. Lower temperature, lower the effect on the rate of reaction. Okay, so the rate of reaction will be lower. Why? Because now the particles will have lower energy, right? Because temperature increase the energy of the particles. If you see, what is the explanation? The particles collide more frequently. Wrong. If you are lowering the temperature, the particles will have less energy. Now they cannot collide more frequently. Okay, that's why the rate of the reaction is lower. So this explanation is contradictory with the option C. Now let's see for higher pressure. If you increase the pressure, the rate of the reaction will be higher because the collision will be more, right? The collision will be more. Why? Because there are more particles in the small volume. What is written here? The particles have more kinetic energy. Wrong. Kinetic energy always depends only on temperature, not on high pressure. Only depend on high temperature. Okay, pressure has nothing to do with the energy of the particle. Now we are just left with option A, that is the right option. Why right? Because if you don't add a catalyst, the rate of the reaction will be lower. Why lower? Because catalyst job is to lower the activation energy, right? But now activation energy is higher. Why higher? Because there is no cat. So when you remove the catalyst, the activation energy of the reactant will be higher. So now the reaction rate will be lower. So that's why option A is the right option. Okay. I hope this point is clear to you. Let's see another example. The contact process is used to convert sulfur dioxide to sulfur trioxide, and the forward reaction in this equilibrium is exothermic. Okay, so this one is the right side equation is exothermic. Which statement about this process are correct? The catalyst increases the rate of both forward and backward reaction. Yes, the catalyst's job is to just increase the rate of reaction. So if you add it in a reversible reaction, it will always be helping both backward and forward. Okay, so option 1 is right. Option 2, a low pressure increases the yield of sulfur trioxide. Let's see the number of moles. How many moles we have here? 3 moles of the react. How many moles of the product we have? Only 2 moles. So if you lower the pressure, the lower the pressure will always help the one that is more. So it will give you more yield of sulfur dioxide, not sulfur trioxide, because if you have high pressure, then the sulfur trioxide yield will increase, because high pressure always help the one that is less in number. So sulfur trioxide is less in number. Okay, so that's why this option is wrong. A low pressure is used to keep the cost low. Yes, that is right. Why we use low pressure in any reaction? Because we want to save the money. Okay, so to keep the cost low, the low temperature is used. Let's see for fourth. A high temperature increase the yield of sulfur trioxide. High temperature can only increase the yield if the reaction is endothermic. But let's see, this reaction is exothermic. So it means the statement is wrong. A low temperature will increase the yield of sulfur trioxide. Okay, you cannot get a high yield if you can get high rate of the reaction by increasing the temperature, but the yield can never be increased if the reaction is exothermic. So you will always get a lower yield. So which option is the only right option? Option 1 and 3. So option B is the correct option. Let's see another question. Which row identified the pressure and the catalyst used for the conversion of sulfur dioxide to sulfur trioxide in the contact process? So now most of the students will think that, okay, we already know that it's the catalyst for the contact process is vanadium oxide. What is the trick in this question? And the pressure we already know it's 2. But the main mistake the student usually do in the exam, they don't look at the unit of the pressure. So the pressure, if it is given in atm, then 2 is the right answer. 2 atmospheric pressure is the right answer for contact process. But if they give you a unit in kPa, then you cannot choose a 2 option. Then your answer should be 200, because kPa 1 atm is equal to 100 kPa. So 2 atm is equal to 200 kPa. So that's why sometimes the student choose a wrong option, that is D. So please be very careful when you are looking at the unit. You have to look at the unit. The pressure unit is atm, so you have to write 2 is the pressure and vanadium oxide is the catalyst. So B option is right. Otherwise, if they ask you in kPa, then D option will be the right option. Okay, so but in this scenario we have B option is right, because they are asking about the atmospheric pressure, not in kPa. Let's see another question that is related to the chapter 9 and is about fertilizer. Most of the time this question come in exam, but the students usually forget about the what are the three main components of a fertilizer that are very useful for the plant. So for that you have to remember NPK. That's why we call such fertilizer NPK fertilizer, because these are the 3 important elements that a plant need for its survival or for its growth. N means nitrogen. Okay, it's the symbol of nitrogen. P is the symbol of phosphorus, and K is the symbol of the potassium. So any fertilizer that has nitrogen, phosphorus and potassium, that will be the best fertilizer for the plant. So where we can find all these three, nitrogen, phosphorus and potassium. So it's simple. You have nitrogen here, but you don't have potassium and phosphorus. You have nitrogen here, you have phosphorus here, but no potassium. Potassium, nitrogen, and but no phosphorus. Here, potassium, you have nitrogen, and you also have phosphorus. So it means option D is the right option. Again, a same question. Why is the fertilizer described as NPK fertilizer? Okay, a fertilizer containing ammonium nitrate and potassium phosphate. Why we call them NPK fertilizer? It provides nitrogen, which is an essential element for improving the plant. Yes, it provides nitrogen, but NPK don't only provide nitrogen. It provides also phosphorus and potassium. So you have to choose an option that provides everything. It contains the element oxygen. It contains the element nitrogen and phosphorus. But where is potassium? Not now. It provides the three main elements needed for the improved plant growth. That's why we call them NPK fertilizer, because it has three elements: N, P and K. So option D is the only right option for this question.